The purpose of this experiment is to extract either a basic, acidic, or a neutral component from an unknown compound. You will be given an unknown compound which you will then dissolve in an organic solvent. At this point, you will proceed with a series of steps that will help you determine if your unknown has a base, an acid, or a neutral component. You may have one or you may have up to 3. The second part of this experiment is to identify your solid using its melting point. Here is a list of the materials you will be using. You will obtain 100 milligrams of your unknown substance. This will be in a solid form. You'll also be using diethyl ether. This will be your organic solvent. You will be using hydrochloric acid, sodium hydroxide, sodium sulfate, and water. Now, there's a couple things to take notice of here. You should notice that your base and your acid are both strong and that they have varying concentrations. Another thing you should take notice of is the density of water versus the organic solvent, in this case the diethyl ether. These few pieces of information will help you understand how a base and an acid can be extracted from a solution. So keep them in mind. Also, don't forget that diethyl ether evaporates quickly, so make sure you cover it with a stopper. Otherwise, you can change the results of your experiment. All of the chemicals used today can be hazardous to the skin and eyes, and some to inhalation, so be sure to wear your personal protective equipment and to do this experiment in the fume hood. You may dispose of the aqueous layers down the sink after they have been neutralized. You may dispose of the diethyl ether in the non-halogenated organic waste. Here's a list of what you will need. You will need a total of 3 test tubes. In this particular case, we used a centrifuge tube and 2 conical shaped test tubes. You will also need a beaker, an evaporating dish, a pasture pipette, and a hot plate. The hot plate will be used to obtain your neutral component. It is essential that you number all of your test tubes and that you place test tube number 2 and number 3 on a test tube holder like this orange one that you see here. Numbering your test tubes will help you avoid any confusion during your experiment. Also, it is highly recommended that you secure your test tube number 1 with a clamp and a clamp holder. This test tube is the one you will be extracting from. This extraction experiment is done in 3 parts. We'll call it A, B, and C. Part A is extraction of the base, Part B is extraction of the acid, and Part C is the isolation of the neutral component. Before we go into the procedure of the experiment, here is a brief overview. This is test tube number 1. Test tube number 1 will contain your unknown compound dissolved in your organic solvent, and in this case it is diethyl ether. For now, let's assume that your unknown compound contains all 3, a basic, acidic, and neutral component. This is how your experiment should go. You will add HCl to test tube number 1. Now you will see a separation in test tube number 1. On the top will be your organic layer, on the bottom will be your aqueous layer, and now your base will be at the bottom with the aqueous layer. You are now able to extract the base at the bottom of test tube number 1 with your pasture pipette, and you can bring that over to your test tube number 2. So to test tube number 2, you can now add NaOH, and when your solution becomes basic, you will get a precipitate. If you do not get a precipitate and your solution is basic to litmus paper, this means you did not have a basic component in your unknown compound to begin with. Next, you will extract your acidic component. This is what your test tube number 1 looks like now after your basic component has been removed. To test tube number 1, you will add NaOH, and now you will see a separation again in test tube number 1. Now your organic layer is still on top, your aqueous layer is at the bottom, and now your acidic component is at the bottom with the aqueous layer. Again, you are able to extract with your pasture pipette and bring this over to test tube number 3. Now your test tube number 3 contains your acidic component, so to that you will add hydrochloric acid, and when your solution becomes acidic, you will see a precipitate. If you do not see a precipitate, that means your unknown compound did not have an acidic component to begin with. Next, you will isolate your neutral component. In test tube number 1, you have your organic solvent left with your neutral component. To this, you will add water, and a drying agent, in this case sodium sulfate. You will then remove the drying agent and then place your organic solution in a steam bath. This will evaporate the diethyl ether, leaving behind your neutral component as a solid. Now that we've gone over the outline, we can go into the steps of the procedure. Here you have test tube number 1. Test tube number 1 contains 2 milliliters of your diethyl ether, which is your organic solvent, and into this you've dissolved 100 milligrams of your unknown compound. The next step is to extract your basic component. So the first thing you do is you add to test tube number 1 ml of 5% HCl. You will shake gently and you will allow the aqueous layer and the organic layer to separate. Once you see this separation, you extract the bottom layer, which is your aqueous layer, into test tube number 2. You will then repeat this step 2 times. What we did next was back extract the combined HCl layers in test tube number 2 by adding 1 ml of fresh diethyl ether. Once you see the separation in this test tube, you will extract the top layer, which is your organic layer, with your Pasteur pipette and bring it back into test tube number 1. The purpose of this back extraction is to make sure you do not leave behind any of your organic solvent in test tube number 2. The next step in our experiment is to treat the combined HCl layers in test tube number 2 with 10% aqueous NaOH. You will add enough NaOH until the solution becomes basic to litmus paper. At this point, you will get a precipitate in test tube number 2 if your unknown compound had a basic component. Your precipitate may now be gravity filtered. In our experiment, we did not get a precipitate, which means our unknown compound did not have a basic component. Although we didn't get a precipitate in our experiment, this is a good place to discuss how you are able to extract a basic component. Let's assume your unknown does have a basic component. We will now break up the steps on this page to show the reactions. In organic chemistry, the common bases we use are amines. Amines are nitrogen-containing compounds like the one here. These compounds also have a carbon backbone represented by the R. The longer the carbon backbone, the less soluble they are in water, which is the reason why we add a strong acid like HCl. This acid will protonate the base and give it a positive charge. This charge will interact with the negative charge on chlorine. This interaction then makes a water-soluble salt, which is why a basic component can be extracted. Let's discuss the reaction that happens in test tube number 2. At this point, your base has already been extracted and is in here, test tube number 2. Then we added a base to this aqueous layer to make it basic. The base we add to test tube number 2 must be a strong base like NaOH. In this reaction, the OH will remove one of the hydrogens from the amine. This will then remove the positive charge, returning the basic component to its water-insoluble form. Since the basic component is now neutral, it will precipitate out of the solution. Now that you have extracted your basic component, test tube number 1 is left with your acidic and neutral component. The next step here is to extract the acidic component, and to do this, you will add 1 ml of NaOH, 5%. You will now shake gently and allow the layers to separate. Once you see the separation, you will extract the aqueous layer, which is on the bottom, and bring that into test tube number 3. You will then repeat twice. Now that your combined NaOH is in test tube number 3, you will back extract with 1 ml of fresh diethyl ether. To test tube number 3, you will now add 10% HCl until your solution is acidic to litmus paper. If a precipitate forms, this means your unknown compound did contain an acidic component, and you may now filter through gravity filtration. In our experiment, we did not get a precipitate, which means our unknown compound did not contain an acidic component. Although we didn't get a precipitate in our experiment, this is a good place to discuss how you are able to extract an acidic component. Let's break up the steps on this page to show the reactions. The acidic component in this experiment was expected to be a carboxylic acid. Just like amines, these compounds have a carbon backbone. The longer the carbon backbone, the less soluble they are in water, which is the reason why we add a strong base. This base will deprotonate the acid and give it a negative charge. This charge will then interact with a positive charge on the sodium. That interaction makes a water-soluble salt, which is why the acidic component can be extracted. Let's discuss the reaction that happens in test tube number 3 when obtaining a precipitate. Your acid has already been extracted and is here in test tube number 3. Next, we add a strong acid to the aqueous layer to make it acidic. The acid we add to test tube number 3 must be a strong acid like HCl. In this reaction, the HCl will donate a hydrogen to the carboxylic acid. This will remove the negative charge, returning the acidic component to its water-insoluble form that you started with here in test tube number 1. Since the acidic component is now neutral, it will precipitate out of the solution. After extracting the basic and acidic components, you will transfer the organic solution containing your neutral component into an Erlenmeyer flask. Next, you will add 1 ml of water. Then you will add sodium sulfate to dry the solution. Initially, the sodium sulfate will form clumps as it absorbs water, but once the solution is completely dry, the sodium sulfate will appear as granules. Once dry, remove the organic solvent with a pipette and place into a new flask. At this point, the ether can be evaporated by steam bath, leaving behind the neutral component in the form of a solid. The reason water was added to the organic solution is to remove any ions that might have been left over. This is important to do to avoid any contamination that can later affect the melting point measurement of the neutral component. If all 3 components were obtained, the melting points of each must be measured. In our experiment, only a neutral component was extracted. Its melting point range was from 95.8 to 97.9 Celsius. Based on this range, we identified the neutral component as a benzyl.